Hey math kids, today we're going to talk about double angle identities. In some ways it's going to be similar to the previous video where we are just replacing things with formulas, essentially. That's how you can think of it. So we're going to start with this. Sine alpha is equal to 3/5. Cosine alpha is equal to negative 4/5. Okay. And then we need to find sine of 2 alpha. We need to find cosine of 2 alpha. Then we also need to find tangent of 2 alpha. Okay, right above this example on page 238, there's some double angle identities, and that's what we're going to be using. And so for the first one, I guess I'll just write the relevant. So sine of 2 theta is equal to 2 sine theta equal to 2 sine theta cosine theta. And so for us, we're going to write 2 sine alpha cosine alpha. And since we know sine alpha and cosine alpha, we can just plug those in. Okay, think of 2 like 2 over 1, so the bottom becomes 25. Negative 12 times 2 is 24, negative, and so that's what we get there. Alright, so for a double angle formula that we're given, the relevant one is cosine 2 theta is equal to cosine squared theta minus sine squared theta. And so for us, we're going to just do cosine squared alpha minus sine squared alpha. Plug in these values, so we get negative 4/5 squared minus 3/5 squared. So we square the top, square the bottom, we get 16/25. Square the top, square the bottom, we get 9/25. If we subtract those, we end up getting, what is it, 7/25. So that's our answer for that one. And now, for tangent, the first thing we want to do is we want to rewrite it as sine 2 alpha over cosine 2 alpha. Now, luckily, we've already found those, so we're just going to put in those answers. So we have negative 24 over 25 divided by 7 over 25. We flip the second one and change it to multiplication. 25's cancel, and so we get negative 24 over 7. Cool. Now let's move on. Okay, so we're given sine alpha is equal to 5/13, and we're only going to look in between these values. So that's, if we look at it, well, we'll do a unit circle. So it wants us to find sine 2 alpha. Okay, so if we're looking at like a unit circle, right, if we're in between pi and pi halves, that means we're in the second quadrant right here. So let's do a different color. Okay, so we're in that quadrant somewhere. And so we know that cosine, so we know that sine is positive, and we know that cosine, the x value, is negative. Okay. And so when we're doing this, we're going to use the Pythagorean identity. So we're going to say sine squared alpha plus cosine squared alpha equals 1. And we need to find our cosine value is essentially what we're doing. So we plug in our sine. So it's 5/13 squared plus cosine squared alpha equals 1. So this is going to be 25 over 169, squaring top, squaring the bottom. And then I'm going to subtract that from each side. And so I'm going to think of 1 like it's 169 over 169, just so we have a common denominator. And so what does that give us? That gives us a 4, 1 over 169. And then cosine squared alpha is equal to that. And so we square root both sides. We get cosine alpha is equal to 12/13. And technically that's a plus or minus. However, we already know that our cosine needs to be negative. And so we're going to now say that cosine alpha is equal to negative 12/13. Okay, now we're trying to find sine of 2a, or 2 alpha. And we know that sine of 2 alpha from our double angle formulas is equivalent to this statement. So we're just going to plug in these two values and figure out what it is. So 2 times 5/13 times negative 12/13. We think of this like 2 over 1. Multiply through on the bottom, we get 169. Multiply through on the top, we get negative 120. And that's our answer. All right. Let's see. Let's have a couple more. All right. So we're given cosine 2 alpha is equal to 3/4. And they want us to find cosine alpha as well as sine alpha. Okay, so cosine 2 theta or 2 alpha is actually, we have 3 choices for double angle formulas. Now, because we're given cosine and we want to end with cosine, I'm going to use the last one that only involves cosine. There's no sine in it. And so I'm going to replace this with 2 cosine squared alpha minus 1. This is an alpha. Sorry, it doesn't look like an alpha. Okay. And we know that that is equal to 3/4. Okay. Now we're just going to go through the algebra to solve that, and we'll be done. So we add 1, but I'm going to think of the 1 like it's a 4 over 4. Actually, you know what? Let's clear the fraction so we don't have to deal with that. So I'm going to multiply every piece by 4. So now we have 8 cosine squared alpha minus 4 equals 3. So those 4's cancel. Okay, so we add 4, 8 cosine squared alpha is equal to 7. We divide both sides by 8. Cosine squared alpha is equal to 7/8. square root, and so cosine alpha is equal to plus or minus square root of 7/8. And oh, in the beginning I didn't see this, but it says it's acute. And so if it's an acute angle, we're just going to be in that first quadrant. And so our x values are positive. And so the final answer on here is just the positive one. Okay. Now we're going to go through a similar process on this, but we're going to use the cosine double angle formula that only involves sine. And so that one is 1 minus 2 sine squared theta. And we're going to once again set it equal to 3/4. Okay, start off similar. We're going to multiply everything by 4 to clear the fraction. And so that's 4 minus 8 sine squared theta equals 3. We're going to subtract 4. Negative 8 sine squared theta is equal to negative 1. Divide by negative 8. Negatives cancel, so we get sine squared theta is equal to 1/8 square root. So sine, I'm using theta, but it should be alpha. I'm sorry, I just realized that. Plus or minus square root of 1/8. Okay, once again, it's acute, so we're just going to use the positive one. So the final answer is square root of 1/8. And we have one more problem to do. Okay. But it has two parts. So 3 sine theta, cosine theta. And then we also have 4 cosine squared theta. No, they don't write it like that. Okay. So 4 cosine squared 2 capital B minus 2. Now the directions for this say, use an appropriate double angle identity to simplify. Okay. So we have a double angle identity that says sine theta times cosine theta times 2 is equal to sine 2 theta. So we don't quite have that. We almost do that. So what I'm going to do to fix this, I'm going to kind of put a 2 in there, but also cancel the 2 out at the same time. So what I'm going to do is in the original, I'm going to multiply by 2, but I'm also going to divide, but like multiply by 1/2 at the same time. Because if I do 2 times 1/2, it cancels it. But now I can link together this and this to become that. And so everything that's involving blue is just sine 2 theta. Now the stuff that's left, we combine that. So 1/2 times 3 is going to be 3/2. And that's my final answer. Okay, so we'll do some other black magic like you did right there on this next one. And so for this next one, we can get, let's see, so we have a cosine squared in there. Okay, so we want to look at this one. We want to see cosine of 2 theta is equal to 2 cosine squared theta minus 1. Okay. So when we're looking at that, we almost have that, right? So if we just take out a 2, like factor out a 2, we'll be left with 2 times 2 cosine squared 2b minus 1. So we think of this 2b just as theta. We see that we have exactly that piece. So what we're going to do is we're just going to write this, but instead of theta, we're going to write 2b. Okay, so all of this. So we get cosine of 2 times 2b. All that's in there. Then we still have that 2 on the outside. All right, so that's 2 cosine 4b. And that is the end. Okay, if you need additional help, come to Math Lab. Until then, calculate.